Mr. Rajat Seksaria, CEO of ACME Group of India, which is also one of the largest solar energy developers and asset owners in India. Mr. Rajat, may you kindly open your camera system and do a brief introduction about yourself?
So my name is Rajat Seksaria. I am the CEO for ACME Group. I'll just take a couple of minutes to introduce ACME and then come to the topic at hand. So ACME Group is an India-based renewable power developer. We have a portfolio of roughly 9 gigawatt, both under operation project and in construction and in development projects. We will be one of the largest solar developers in India. We will be one of the top 3 solar developers in India. And ACME is known in India primarily for its technological innovation and for bringing the cost of power down in India. So ACME Group was the first company in India which brought the solar power tariffs to around 3 cents to a unit, which was done in 2017. That was the lowest. This was the lowest project we had. That was the lowest tariff project that we had developed, and even today that continues to be among the lowest tariff project which is commercially run in India. Now, around a couple of years back in ACME, when we were strategizing, we realized there is only so much you can do in terms of producing more solar, and the real problem of decarbonization is not in power, but the real problem of decarbonization is in the non-power energy sector. Everyone knows that only around 20% of the power that globally we consume, only 20% of the energy we consume is in form of power. Almost 80% of the energy we consume is in form of other sources, including hydrocarbons. So that is an area we thought is a real problem area which also needs to be attacked and solved by renewable developers. And that is when around 2 years back, we had taken a bet that we will move into the field of green hydrogen and derivatives of green hydrogen. So when the world had not started talking too much about it, almost 2 years back, we started investing in a small plant in India in a place called Bikaner, which is in the province of Rajasthan. And this plant has solar modules, it has electrolyzer, and it has ammonia synthesis groove. This plant we have physically completed just this month. And to our knowledge, this is probably the world's first integrated solar, electrolyzer, and ammonia set up at one location. When we were working further, we realized that one of the biggest challenges for adoption of green hydrogen or green ammonia would be to produce the product at very, very cost competitive rates. And this was because while the world has been talking a lot about green decarbonization, hardly any country still today has a very specific policy in terms of giving special financial incentives so that green products can be sold at a different price. There are multiple talks, multiple policy which people are talking, but as on date, we still don't have a proper policy which can give you commercial advantage in green hydrogen or ammonia. So we realized we need to produce the end product at a very, very competitive rates. And then we realized to produce the green hydrogen, almost 70% of the cost is the cost of renewable power. And we then backward calculated and realized the cost of renewable power has to be 2 cents to a unit or lower for the green hydrogen or green ammonia to be something which is cost competitive. And then we started scouting for various places globally. We realized there are few geographies like Chile, Western Australia, some places in Gulf, where you can get good radiation, solar radiation, and good combination of radiation and wind, where you can produce solar power at a competitive rate. We started discussing with various governments, but the government that we got good traction was the government of Oman. And sometime in early this year, we signed a facilitation agreement with Oman, and we decided to make a large investment in Oman, where we are setting up a 2,400 tons per day green ammonia facility. To put 2,400 tons per day in perspective, 2,400 tons per day would, on an annualized basis, mean roughly 0.8 million metric tons per annum. And again, to make it a comparison, the NEOM project, which is one of the best known projects which is being developed, is roughly 1.2 metric million tons per annum. So the project we have is smaller than NEOM, but not very small. So we are at 0.8 million metric tons per annum. We then realized that the global appetite for funding this kind of projects, at least the first of its kind project, may be slightly low. So we modularized the 2400 tons into modules of 300 tons per day. Each of these modules was identical in nature and could be expanded as the demand grew. So we have started pre-construction work for the first 300 tons per day module in Oman. We already got the land, a large piece of land from government of Oman. We have started all the basic studies that are required, the environmental studies, the hydrological studies, the topographical surveys. So all those works have already been started. We have already made our technology selection for ammonia for this project, and KBR is our technology partner. The media announcement for the same was just made, I think, around 10 days back. So KBR technology will partner with us for this project. So this is the project that we have developed, and we are developing in Oman, and we are targeting that sometime early next year, first quarter of next calendar year, we should be able to break ground on this project. And another 18 months from then, we should have the first green ammonia produced for shipping out. So this is the journey we have till far. So we already have a small demo plant. There is a large master plan of project that we are developing in Oman. We are in discussion with multiple countries to set up similarly sized large plants in places like Australia, Chile, and some of the other countries we are discussion with. So before I go forward, Molly, I just want to show a small video of our Bikaner plant, which is now physically completed, already producing green hydrogen, and has just started producing ammonia. So maybe if you can run that video that we were talking for a couple of minutes, that will give a small glimpse of how a typical integrated solar electrolyzer based and ammonia based plants looks like. So my request to you, Molly, if you can just play that video for a couple of minutes.
Sure, will do. Just give me one moment. Let me share the screen.
Welcome to the world's first green hydrogen and green ammonia plant, developed by ACME Cleantech Solutions Private Limited, a true example of Make in India. The plant is located in Bikaner in Rajasthan, India. Here, renewable power generated from solar PV plants is used to produce green hydrogen. The nitrogen is captured from atmosphere. Using this green hydrogen and nitrogen with the Haber-Bosch process and ammonia reactor, green ammonia is produced. The complete process is carbon-free. Renewable power is supplied from an integral part of the project, a 5 megawatt peak solar PV plant, also expandable up to 10 megawatt peak. Green hydrogen is produced by splitting purified water molecules into oxygen and hydrogen without using fossil fuels, using an electrolyzer. This technique is very clean and produces more than 99.999% pure hydrogen gas. The air available in the atmosphere is pressurized through the air compressor and being buffered by the filter and air dryer. This process produces 99.5% nitrogen. The green hydrogen and nitrogen are mixed and preheated up to 200 degrees Celsius. The product stream then enters into ammonia synthesis converter. Then it's further heated to 360 degrees Celsius. The final product is ammonia after being cooled in subsequent heat exchangers like cooling water exchanger, cold heat exchanger, and ammonia chiller up to -20 degrees Celsius. The produced liquid green ammonia is stored in the pressurized vessel, which can be transported to anywhere in the world. Green ammonia can be used for power generation, marine fuel, fertilizer, and various other industrial applications. This is also used for hydrogen carrier for bulk transportation of green hydrogen from one place to another. By using world-class technology, the process is 100% emissionless. ACME, leading through innovation.
Thank you, Molly, for playing that video. So I just wanted to tell the participant that that small audio visual was actual videography of the plant that we have completed. It is a 5 megawatt solar panel based plant but this is a semi-commercial steel plant, which is something we started working almost 1.5 years back. And as a team, as a company, it has given us a lot of learnings, which we are going to now incorporate as we do industrial scale plants in this sector. So this was the brief introduction about the company ACME. I think I would now spend next few minutes kind of sharing some of the experiences and some of the challenges that we are either facing or likely to face as we become one of the prominent developers of green hydrogen and green ammonia project. I think the number one challenge which all developers would face, that this particular sector is effectively a marriage of power sector and industrial gases sector or oil and gas sector, right? Which these two sectors fundamentally commercially operate in a very, very different way. A lot of power that we as renewable power developers have over the years developed, or projects that we have developed, is on the basis of long-term 20 or 25-year power purchase agreements, fixed price power purchase agreements in many cases. So that underpins the economics. But unfortunately, a lot of hydrogen, or more specifically ammonia, which is sold, is not sold on a long-term fixed price basis. There could be a long-term agreement, but many of the contracts are actually sold on a spot prices basis. So that is where the commercial risk gets accentuated, as it is difficult for both the equity investor and the debt provider to know what would be the actual revenue from the plant. So this is the number one challenge that I think solar developers would face. So the option is either doing the plant through full equity, in which case the cost of equity is more and the end product will be costly, or project financing will be difficult until someone can manage and get a large long-term contract with some assurance on the price. The number two challenge that people would face is, effectively there are three different sectors which are being three different projects which are being kind of integrated. There is a renewable power, which for example companies like us understand. There is an electrolyzer and there is ammonia. So there is very less common knowledge bank that any company has. Typically the companies who have been operating in either of these fields are mutually exclusive. Same goes for the contractors or the operators, right? So effectively what we are doing is we are getting electricity and chemistry mixed. And there is, while the technologies have been around for multiple years and decades in the case of ammonia and hydrogen, but no one has an experience of operating such a large variable power based plant running hydrogen and ammonia. Ammonia, as you all know, is a process plant, and process plant typically performs best when it runs in a 24/7 mode. But the challenge here would be the power that one generates either through solar and wind or through a combination would be very variable in nature. So how do you size the plant? What are the kind of algorithms you develop? What storage of ammonia you create? What storage of hydrogen you create? How do you assure a constant supply to your off-taker? A lot of demand people would have as off-takers is that while they are willing, they may give you take or pay obligation, but they would expect a supply or pay counter clauses. So as a variable power which is powering your hydrogen generation or ammonia generation, how do you assure a constant supply? That is another challenge people would face, and they would have to find their own ways of finding solution to this problem. Third problem that developers would face, we are facing that challenge, but we are making progress, is while a lot of financing entities are well intentioned, they have the mandates to do green projects, but none of them have ever done such kind of a project. So I see a lot of conservatism there, a lot of apprehension. So not many are willing to bell the cat. Everyone is looking towards each other, but we are not still finding leaders on the financing side who would say, okay, we'll take this thing in the larger interest. And so there is still a tentativeness among various financing institutions. The fourth challenge that people would face is that typically places which have good solar radiation or good wind loads tend not to be the markets of this product, right? So let me give an example. The most likely market for ammonia and hydrogen could be, say, Japan, or maybe some parts of European countries, but then they are possibly not blessed with the kind of solar radiation. So you will have to produce these products in areas which are probably not very close to the consumption hotspots. So how do you create that logistic infrastructure? How do you create those those kind of integrated contracts which takes care from feed till the final consumption concept. This is another challenge that people are going to face. Fourth challenge is, the last challenge is the capital cost. I have still not come across people who know with certainty what is the capital cost, right? A lot of costs are changing. Unfortunately, last 3 to 6 months, we have seen huge variations and increase in commodity costs. Commodity cost, whether it is solar panels, steel, it is some of the other components which goes into these plants. So in the face of such high cost, how do you still produce a cost competitive end product? So these are some of the challenges that I believe solar players will face initially. One more challenge that I would highlight before kind of I pause is long-term contract. The fear a lot of off-takers is, what if in 10 years time or 15 years time the prices drop? So they don't want get locked into a contract which is attractively priced today, but may not be that attractive, say 10 years down the line. But so that is a challenge a lot of these off-takers are facing. So these are some of the challenges we are facing. I can tell you that company like ACME, which is probably not as big as some of the oil and gas companies, but we are a nimble-footed company. We are an entrepreneurial company, almost a flavor of a startup. So we are able to take a lot of decisions. We are able to do a lot of course correction. We are able to kind of move at a much faster pace, spend much of our energy developing this project. And we are very, very hopeful that we will, as a company, be among the first players to bring ammonia, green ammonia and green hydrogen at an industrial scale. For our case, being an entrepreneurial company, we have chosen our horse. We have taken that leap of faith. So we are still not tentative. I think that's the decision we have made, and we are already investing money in this project and attracting very, very good names as we go forward. And people who are interested in these sectors would hear a lot about us and some of the partnerships that we are striking in the sector. So for the moment, I think I have packed in a lot of stuff. I would just give a pause, and I would be very, very happy to take or dwell on any of the factors that I have discussed in my project, in my short speech, and maybe answer some of the queries that you may have.
Yes, of course. Let's start with one question from the audience Q&A from Saif. He says, thank you very much, Rajat, for the informative presentation. First of all, what are the key factors that ACME have considered for feasibility to select Oman precisely as a location for hydrogen and green ammonia production? Why this country? Why this land?
I think that's a very, very good question. See, we are an India-based developer. All our solar projects we have done in India. We have done 56 projects in India. And India also has relatively good solar resource. But when we were doing our calculations on how can we produce at the almost the best possible price, Oman was one of the geographies which came up in that equation. It was not only Oman, it was a few other geographies that I earlier mentioned. So we started dialoguing with all these geographies and the authorities concerned. Oman is where I think we got good response from the concerned authorities and the government. On top of that, we are doing project in a place called Duqm, which is a very, very strategically located port come SEZ. And there are, I think, a couple of other players also trying to develop it. So the advantage it has is, from a logistics point of view, it's very well connected. It has good solar resource. It has one of the very rare places which also coincidentally has very good wind resource, right? So you can kind of almost do a hybrid renewable power project. Though in our first phase, we are doing solar, in second phases will include hybrid. So these are the advantages it has. And one more advantage is which is not obvious, but someone who understands solar sector would understand, the relative temperatures in Oman are a bit lower compared to some of the other areas in the region. Why lower temperature are important? This may sound counterintuitive, but you get actually better solar radiation if you are closer to 25 degrees, right? So a place with say 30 or 35 degrees is much better than say 40 to 45 degrees centigrade temperature, because there is a negative coefficient of solar generation with temperature. So this temperature profile also kind of helped Oman. So I think it was an overall package that we could get, and we could get very good piece of land in Oman, you know, and since government was very keen on developing this particular area as a hub of green hydrogen, we could get good kind of facilitation in terms of fast-paced decision making. And that is why our first large project we are doing in Oman. Having said that, we are in discussion with at least 2 or 3 more geographies where we would like to put plant of similar size. If we have representatives from other countries who are attending this and they are interested, inviting someone like ACME, will be very, very happy to consider their place in geography as well.
Yes, you are absolutely right. Oman, you just mentioned the port of Duham, and we also have a port of Sohar, where we can have a lot of international knowledge transfer between Oman and Netherlands and Belgium, for example. And also, one more question from the audience with regards to cost competitiveness. As you mentioned that for demonstration projects, it can be very costly for the early stage capex. And what's ACME's strategy to reduce the cost, to reduce the, or in the future, how would you plan to reduce the compression, storage, and distribution costs?
So I will only give a slightly more general answer to this. Some of these are a bit IP related, so I can't go into depth. But see, the cost reduction that one needs to achieve is not only on the compression and storage cost, it has to be across the value chain, because we are treating this as an integrated project, right? Whether it is renewable park or is it electrolyzer or it's ammonia or say compression and storage, right? So we are looking this as a complete chain. And one thing that we have realized that someone, in order to reduce the cost, needs to establish a global supply chain, right? And we have seen very categorically that some of the items that is mentioned here or I have mentioned, between various geographies, the cost could be very, very different, right? The challenge that people faced, a lot of these items were not done at the scale that we are envisaging. So one needs to be able to leverage the ability of scale. Secondly, for each of this component, one needs to do a very, very basic grounds up analysis of what constitutes the cost, right? How much of steel goes into this, how much of it is a technology cost, right? And that is where you can do the vendor, you can do a kind of vendor development play also. One thing which I think is important, which worked well in say solar, which could work well even in hydrogen ammonia, that we cannot allow the market to be a 2 or 3 player market in terms of vendor suppliers. The real cost advantages would only come if we can have a globally as an industry a much larger vendor base. That is where the real efficiencies in cost come in. The areas where we have globally 2 or 3 or 5 vendors only, that is where we see that cost is not something which one can really manage. So it is important to diversify the global supply chain, use a global supply chain, and have vendor development efforts. Then only I think we can reduce the cost. Because if you just start integrating a plant based on the best names available, right, only the best names available, you may find that the cost will be so high that the end product will not be competitive. It will not be bought by any off-taker because it will be big risk for the off-taker.
Yes, great explanation. And ACME also has projects in India, similar projects in India. Can you suggest the price per kilogram in case of green hydrogen in India? What's your estimate on the price of green hydrogen at the moment, and as well as the price in India right now?
Okay, so I will give ranges, Molly. As you can understand, it's not possible for me to give exact number. So a green hydrogen in India should cost around $2.5 to $3 a kg in India right now, because there is a taxation and some of the other costs also involved. A similar project in a good location, say Oman or some other countries, a good developer can target a green hydrogen at around $2 or maybe even a kg.
Okay, I think our audience, Herman, shall be satisfied with your answer for the moment. And as you also mentioned, you are encountering quite a lot of funding issues, the funding challenges. What are the final offtake options for green H2 and green ammonia, in your opinion?
A couple of things which is important, Molly. See, this is a new industry, we all know, in terms of taking it to industrial scale. So we need to all see what is the path of least resistance, right? The path of least resistance in developing this industry right now is selling ammonia and not hydrogen. So we don't believe hydrogen will become industrial scale in next 2-3 years. It will still take some time. The applications and the use cases are still being developed. Fortunately for us, ammonia, which is a carrier of hydrogen, has a ready-made application, as I think your earlier speakers were also mentioning. So there is already 180 million tons of ammonia annually consumed. Most of it is gray ammonia, right? So if someone can produce green ammonia at cost which are not too much higher, a bit higher maybe because of green component, we have a ready-made market which we can target, right? The challenge on the funding side is not that the funding is not available. There is so much of liquidity globally. So many institutions have the mandate to specifically do projects like this. For example, in our project, World Bank is willing to fund it. The challenge is because this is something unknown for many people, right? So they are taking probably the level of analysis and due diligence will be a different kind. And that is where I think the challenge is for eventually for them to take decision. In a normal renewable project, they would have decided in say 2 months time. Here they may take 3 or 4 months times for getting through a cruise. So that is a challenge. The second challenge which I mentioned, but I'll not give the solution. The solution was there in the question is, it is ability to get a long-term offtake agreement, right? If you can't get a long-term agreement with some price assurances, it would be very, very difficult for project financing institution to give you a long-term fund. And if you don't get long-term fund, then the viability of the project will go for a toss.
Yes, thank you so much for your kind explanation. And I think it's a great input for our concluding session of today, which will be the funding, the capital and the funding support to make MENA hydrogen succeed. And we have 2 multilateral banks who are ready, who are committed to reduce emission. And let's hear what they will say at the last session. And it would be great if you can stay and listen.
Thank you.
And thank you so much, Mr. Rajat, for having you here. I know it's quite late in India, and I hope you enjoy it tonight very well.